And if I can get everybody up on your feet, please. Okay. Suddenly, if you just want to like watch the motions, that's great. You weren't here to partake in the insanity. Okay. Here we go. We're going to do this all together on the count of 3. Cynthia, why don't you come over here so we're focusing on the good-looking kids over there. We've got the words up here. I care greatly about the moves because the moves are going to make it sticky. Miguel, you're going to join us?
Yeah.
Thank you. Okay, on the count of 3. 1, 2, 3. In order for a function to be continuous, there can be no holes, no jumps, no breaks, and no vertical asymptotes. The hole is considered a removable discontinuity. It is interesting to watch those of you that are hiding behind others because the camera is out. Jaylene couldn't be more in the corner if she could. Okay. Here's the tricky part. This last part you did last year in pre-calculus. It's this next part. We talked about like proving continuity, right? There is a process that we go through, and I am ruthless. That is the word I want you to have in your head. I am ruthless with this process. Oh, awkward. Okay. In order for a function to be continuous, we did this yesterday, so one more time. In order for a function to be continuous at a point, the function must satisfy 3 conditions. Number 1. Right, that's why we're doing the speed bag, right? There has to be a point there. Number 2. Oh, so awkward. We're getting the words, we're forgetting about the hand motions. But Irene, I care a lot about the hand motions, right? Why are we doing this, Irene?
Because you need the limit if x approaches b from the left and right to be.
We need the limits to be equal to each other, right? Okay, condition number 3, the limit as x approaches c equals f of c. Why am I doing this? What's the significance of this? Hector, what's the significance?
Well, at first it's
right? When we find limits, we've seen functions where like the limit exists and there's a hole. You need to close that hole if you're going to be continuous. Okay? If the function fails either one of these conditions, the function is said to be discontinuous. Okay, let's do it together one more time with really high-pitched voices. Think back to like 4th grade, 5th grade. Your voice was changing on a regular basis. Okay, on the count of 3. 1, 2, 3. In order for a function to be continuous at a point, the function must satisfy 3 conditions. Number 1, f of c is defined. Number 2, the limit as x approaches c exists. Number 3, the limit as x approaches c equals f of c. If the function fails even one of these conditions, the function is discontinuous at c. Great, have a seat. Woo. Give me my water bottle. That just about killed me. All right. You are so good to me. Thank you, thank you, thank you. All right, I want to go through and I want to do this one model problem with you guys. Remember model problem? I put a little star next to that. Okay? This is from yesterday's notes. That's why I told you guys to take them out when you first came in. Yeah. Okay. So prove that f of x, which is equal to this piecewise function, is continuous at x equals 1. It says prove I'm continuous at x equals 1. I hope everybody knows how we're going to start. What are we going to do first?
evaluate.
Right, the first thing is I need to know that f of 1 exists. So I'm going to go find f of 1. Go find f of 1. You got to ask yourself the question, well, how do I find f of 1? I'm going to plug in. It's an evaluate kind of step. But piecewise functions, I know we sometimes start making like weird things happen with piecewise functions. Which piece?
Ex minus 1.
The second one.
It's going to be the second one. We look at the domain restriction to decide which one we're going to use. So f of 1 is going to be e to the 1 minus 1 minus 3. Does that exist? Is that a number?
Yeah.
Sure. Simplify if you want to. I know that 1 minus 1 is 0. So e to the 0 minus 3. E to the 0 is 1. I get negative 2. Great. Have I shown continuity?
No.
No, why not? Abel, why not?
Because you get a number.
There's another reason why we haven't shown continuity. Check your notes. It's totally okay. How do we prove continuity?
You need to do the next.
Now we need to look at it's a 3-step process. The first thing is f of 1 exists. Step 2, what was step 2? I need the limit as x approaches 1 of f of x. And here's where you need to be really careful. Which side? Which side? Both sides. If the limit's going to exist, both sides. So I have to go over here and say, oh, that means I'm going to find the limit as x approaches 1 from the left, and I'm going to find the limit as x approaches 1 from the right. If I'm using numbers to the left of 1, examples, just call them out. 0.0, 0.01, 0.9, right? They're all to the left of 1. What they have in common, they're all less than 1. So I want to find the limit as x approaches 1 of 2 cosine pi x. For the limit as x approaches 1 from the right, it's e to the x minus 1 minus 3. I want to evaluate the limit from the left. I want to evaluate the limit from the right. What are we going to do? Right, we're going to plug in. We're going to do that direct evaluation. 2 times cosine of pi times 1. Pi times 1 is pi. Cosine of pi?
Negative 1.
Those of you that are smiling, hoping other people are going to say it, think about your unit circle. Cosine of pi is negative 1. So I've got 2 times negative 1, which is negative 2. Over here, it's e to the 1 minus 1 minus 3. I can do that. 1 minus 1 is 0. E to the 0 is 1. 1 minus 3 is negative 2. Have a quick conversation with somebody near you. What did we just show? What does that work prove?
Those are the vertical asymptotes. I believe those are the vertical asymptotes.
Okay. I heard somebody say... Okay, let's close that. I heard somebody say it shows that we have a vertical asymptote. I heard somebody say it shows that the function is continuous. I heard somebody say that it means that this exists. The right answer? What did we just do? We found the limit from the left. We found the limit from the right. We see that they are equal to each other. What did we just do? Janaea, what did we just do? Well, I don't know that we've done that. What we just did here, the limit as x approaches 1 from the left is negative 2. The limit as x approaches 1 from the right is negative 2. Hector, what did we just do?
You prove that the function is continuous.
We didn't actually show the function is continuous. We showed the limit from the left and the limit from the right are equal to each other. What did we do?
We show that they exist.
What's the they? What exists? We showed that the limit as x approaches 1 of f of x exists. That's the only thing that we've shown right now. Okay, it exists because they're equal to each other. Not done. Because the third step, right, the third step says I need to know, let's see, is f of 1 equal to the limit as x approaches 1? Are those equal to each other? F of 1 is negative 2. The limit as x approaches 1 is negative 2. Since they're all equal to negative 2, I'm going to put these little 3 dots. I don't know if you guys have seen them before. That means therefore. Even though there's only 3 of them, it's therefore. Okay? Since this is true, therefore my conclusion is that f of x is continuous. Be careful. Don't be too strong. I know you think about me and you're like, he's so strong. Oh, there's the laugh. Okay. We didn't just show f of x is continuous. We showed one thing. One thing only. Where is f continuous, Alejandro?
X equals
All that we did, we showed continuity at one point. All that work was for one little point. Your conclusion is that f is continuous at x equals 1. Done. Questions on what we just did? I'll take anything from anybody.
So if like let's say for the rule 2 we didn't get them as equal, so that automatically means that it's just not.
Oh my God, I love that. So you said like if we got different answers. Limit from the left is -2, limit from the right is +2. What would you say?
It's not,
We would say
it's not continuous.
the limit doesn't exist, right? And if the limit doesn't exist, what else could you say, Salma? The limit doesn't exist. So his question is, what if we got different values here, -2 and +2? Okay? We'd say the limit doesn't exist. If the limit doesn't exist, could the function be continuous?
No.
It can't be continuous because three things are true. The function is defined, the limit exists, and those two things are equal to each other. Okay, Alex?
In order to prove the whole function is either continuous or not, we had to, instead of using as x approaches 1, we had to replace it with infinite instead to concentrate on.
That's a really good question, right? This is so focused on x equals 1 right now. We are going to have that other conversation, but in a little bit.
All right.
So here's what I want to do. I want to give you guys 3 minutes to do one problem completely on your own. This is in your journal entry. Use this one as a guide if you want to. Okay, this is your opportunity to earn a sticker and let the world know how brilliant you are. This is not for a grade. This is just an opportunity. So it's problem number 1 on the journal. Excuse me. You've got 3 minutes. Don't get any help from anybody. You're going 100% solo. I'm going to be such a proud papa. Give away all these stickers. But remember, I am ruthless. I can get everybody to stop just for a second. So I just did a quick lap around the room, and I saw these 3 things on 3 different pieces of paper. All of them are problems. Anybody see any of the problems? Remember, I am so picky. So picky. Salma, something that you see that's wrong.
The F is supposed to be a G.
What?
The F is supposed to be a G.
There is no F in this problem. The function's name is G. Other problem. Other problem. Jasmine.
Oh, for limit, it should be g of x, right? Like next to.
Okay, first of all, there should be a name there. So you want a function name there, g of x, still a problem. In fact, now even worse. Brianna? Oh, that's not the problem. I'm glad you brought that up. Shunli, what's the problem?
It's g of t, not g of x.
One more time.
G of t.
Your independent variable is wrong. G is not a function of x. So don't write this when what you really mean is limit as t approaches 3 of g of t. I told you guys I am ruthless when it comes to this. I'm making you better mathematicians. Thank me later. Alex?
For the square root, don't you set g of 3 equals to 3 plus 1?
Yeah, this guy here, this like operation floating in outer space, but I don't really know where it's coming from. Where is it coming from?
G of 3.
You're finding g of 3. Okay, finish it off. I bet everybody's going to get it across the finish line from here. Another minute. Oh, or I'll start the clock. Good news, they're not going to take points off on the college board for your handwriting. Whoop. Okay, so just so that you can compare, and if you have a perfect paper, you can get a sticker, I promise. Number 1, you found G of 3. G of 3, maybe you went straight from G of 3 to 2 because that's fine. Okay? Limit as t approaches 3 from the left, I have to use the left function. I plug in, I get 2. Limit as t approaches 3 from the right of the right function. 5 minus 3, I get 2. Love it. Therefore, limit as t approaches 3 of g of t is equal to 2. How many guys made it up to here? Nice. Number 3, since g of 3 equals that limit as t approaches 3, g of t is continuous at t equals 3. It has to be at t equals 3. Otherwise, what you're saying is g of t is continuous where? If you just write this, what this means to me is g of t is continuous
Everywhere.
everywhere, all of the points, all of the places. And guess what? You didn't do that. You didn't do that. So I'm going to put some stickers over here. I'll put some stickers over here. If you have a perfect paper, feel free to put your sticker on there. And we've only got about 4 minutes left. I want to do a challenge problem. I want you to do this. I want you to look at this problem. Have a quick conversation with somebody near you and identify anything that you think is going to be challenging about this problem. So read it over, have a conversation.
So the first problem I see is that the first question says x is not equal to 4, and I really think that that might confuse someone. Oh, and it has 2 variables. It has a k and it has an x. So we won't know. No, we're trying to find k, right? But it
Good question. We'll talk in a bit.
So we have 2 variables.
All right, friends. I'm not interested in how you would solve this. Anything that is confusing about this problem, anything that you think makes this challenging. Janae. Okay, so maybe this notation is a little bit new for us. What does that mean? That means x is not equal to 4. Okay, Alex, something else that's confusing.
Well, for the square polynomial, I saw that instead of x squared minus 16 is kind of backwards. So that means you could confuse yourself because I think you have to multiply times -1.
All right, a lot of you guys, when it comes to factoring, we're still having some problems when I do like the number first, right? So like that's an issue that maybe some people are going to struggle with. Brianna, what else?
When it says x equals 4 and there's a different variable.
Okay, we're talking about x equals 4 over here. X is the variable. Specifically, it's your independent variable. But then we're talking about k? What the heck is k?
K.
K? It's a letter. K is some other variable. It's some other variable that you're trying to find. It is a constant. It's a constant that we'll figure out eventually. For now, I'm going to call it a parameter. The goal in this problem, we only have a minute. We're just going to start the conversation. That's all. The goal is to find what is the just right value for k, that just right one, so that this function is continuous. Should I say that again?
Yeah.
Yeah. Okay, the goal is to find there's one value for k. What is the just right value so you get a continuous function? Follow me. Wait, do you have a question?
No.
Okay. So let's at least get this started. If f of x is continuous at x equals 4, what do we know? What do we know? If the function is continuous at x equals 4.
Plug it in and work it out.
We can plug in 4, right? I think what you said without being so fancy is that f of 4 exists. The other thing that we'll know is that the limit as x approaches 4 of f of x exists. And more importantly, that limit as x approaches 4 of f of x is equal to f of 4. We're going to finish this up tomorrow, so goodbye friends all over the world.